Hello, my name is Mario. Welcome to another Go video. In today's episode, I'm sharing with you the changes in Go 1.21. I know this is not current news, but I still want to cover it. Go 1.21 was released on August 8th, 2023, and actually at the time of this recording, Go 1.21.1 is already available as well. So there are packages for all the platforms and for all the different ways to install it. I typically use Homebrew, but you can use whatever you want depending on the platform. The Docker images are also available for Go 1.21.1 as well. So what are the new features that I want to share with you? There are 7 features I want to call out. Let's start with the most popular one, the addition of the slog package to the standard library. I covered the experimental version of that package in a previous video. I'm going to be leaving the link in the description to that video so you can check it out. Practically, the code that I showed before is equivalent to the version when you use the standard library. The second new cool feature is the support for Go Toolchains. What this means in practice is that now, starting with 1.21, you will be able to pull runtimes previous to the version that you're using when you're compiling a binary, depending on the Go module of the package that you happen to be using for building that binary, and also is applicable to the future versions. What this means now is that if you happen to have 1.21.0, you should be able to compile any version that the specific dependency explicitly indicates. This is cool because you don't have to now go and explicitly install a Go version for building a package or for building a binary that you happen to need. The next feature I want to share with you is Go debug. This is a new directive that is equivalent to the existing Go debug environment variable that you can use to indicate a different behavior when you're running your Go binary. Let me show you an example that I use for Go 1.20 that is applicable to the tar package that indicates, or rather prevents, some security concerns when extracting files. Let me show you the code. I have my main.go and there is an important directive right here. What this means is that the Go debug variable, if it doesn't exist or if it's not passed in during the runtime of this binary, it will say, I want to override the previous behavior and I want to start using the new behavior. And the new behavior means I want to fail if there is a non-secure file that's trying to override an existing file. So if we close this and then we build our binary and then we run it, you will notice that it's printing out this error, and it's printing out that error because the file itself that I said before is trying to override that value. But what if we don't want that behavior? We really want to keep things compatible with what we had before. Well, we have to go and change the directive, and instead of using 0, we use 1. And we recompile this and we run it again. And now you will notice that it will not fail. It will print out the unsecure file. Now, this is a behavior that probably you want to keep because you want to build secure applications. But in this case, maybe there's some logic that changes and you need to still continue supporting the previous implementation. One thing to keep in mind with this directive is that Go debug environment variable still has the higher priority. So if I go back and I override it so it uses the implementation that I had before, it will still go and honor what I had in the environment variable. The next feature is the addition of 3 built-in functions, min, max, and clear. Let me show you. Min and max are where you probably are imagining. Min returns the minimum value of the values that you pass in. It's applicable only to order types. Max is similar. It uses the maximum, again, for only order types. Now, the important bit that comes next will be using clear. Clear applies to slices and clear applies to maps. For example, I have a slice that is of 2 values, hello and world. It will print out what you expect to print out. But if you call clear, it will actually make the values empty. It will not remove the values, but rather make them the empty 0 value. When you use clear, it's slightly different, and let me show you what I mean. So if I compile this, and if I run it, you will notice that now the map, it doesn't have the values. Compared to the slices, if you notice, the values were still there. The allocation of those slices was still there. But in the case of the maps, they are literally removed from the map. They're still pointing to the same space in memory. And similarly with the slices as well. This is an important thing to keep in mind when using the min, max, and well, in this case, the clear built-in function. The next feature is a new package called slices that includes some common operations applicable to slices. Let me show you the example. Now in this code, I'm not using all the different functions that are available, but I want to show you a few of them. So index returns the index of the value that you pass in. So in this case, the index of 1 will be -1 because it's not found. The index of 2 will be 1 because it's right here, 0, 1. Now there is something similar for sort that sorts the slice that you pass in. As you can see, the sorting is in place. It doesn't return a new value. Another function is the min and max, and similar to what I showed you before with the built-in functions, they do something more or less equivalent. It returns the min returns the min value of the slice, max returns the max value of the slice. So they're kind of the same. These are not the only functions that you have in the package. Like I said before, there are more. I highly encourage you to look at the functions because most likely you have something that can be useful for your different use cases. The next feature I want to show you is the addition of a new maps package that applies to the map type that includes common functions. Let me show you code. So in this example, I'm not using all the different functions available, but there are some of them that I think are worth calling out. So we have cloning, we have equal. We can actually now start doing a copy of the values. And another one that I think work call out is this delete function that you can specify how to delete values in your map according to a function that you can pass in. If we compile, let me compile this, I'll show you. So we have the cloned is using different values. And what I mean is this value, this pointer is obviously created to different maps. And the other one will be like the delete that I showed you before. Is using anything that is higher than 90, it will be gone. So I have Mario 91, it will be gone in this example. Similar to the slices package, there are more functions that I highly encourage you to check out on your own. Let's look at the next feature. The next feature is the addition of new functions to the context package. There are 4 new functions added, 3 of which will allow you to start your context interaction in different way. Let me show you an example that I have right here. Let's start with without cancel. This is a new function that was added that, as you may imagine, it will return a context with no cancellation. Notice that although I have a timeout here, the context without cancel will not return the error. So when this is executed, it will not print out that the timeout happened. This is an example where probably you don't want to propagate up what happened with a previous context. You want to just stop it right there. Next one will be with a deadline, because this is similar to the one that already existed before with deadline. The important bit to call out here is that you can indicate the error that will be triggered when the context is completed. So for example, you can say that the deadline will fail with this error, not with any other error the previous context indicated. This means that when you're calling in the cause, it will actually print out this error that I have right here, which is different to the error that you have in the deadline. Now, what is the use case of this one? Well, you can use it to explicitly indicate what caused the issue, therefore ignoring the original reason it failed. This could be useful when dealing with third-party APIs where you explicitly indicate the call failed instead of indicating the concrete reason. Another one that I want to call out is context after func. This is an interesting one now because now you can pass in a function to call when the context is completed. So in this case, I have my after func function that I'm passing in, and I'm saying just print out called and actually close the channel. So what is going to be happening is that I do a timeout. It will wait for 10 seconds. It will complete and it will close the channel when the timeout expires, and it will just say, okay, deadline complete. Now this is a use case that probably it could be useful to trigger a new workflow after a context was cancelled without affecting the original context cancellation workflow, something async, for example. Now let's look at the next feature I want to share with you. This new feature includes the addition of 3 new functions to the sync package. This is to lazily initialize a value on first once, similar to the way sync once works. And a once value, there's another function, and once values as well. Let me show you the code so it makes more sense. So what is going to happen here is that this once string is going to be called once you call the function itself. Now this is quite interesting because it won't be called unless you call the function, but it will be initialized once. Now there is another one called onceFunc, and onceFunc uses a function instead of a value. Both of them are kind of similar, so let me show you actually how this works in real life. You notice right here that these are for once value. If we look at the code, you will notice that I have a sleep here. So I'm only called once, therefore I'm only sleeping once. So if you look at the time it waits, you will notice that it was called once. Similarly with the computed once function, we look back to the code, you will see that it's sleeping once, but it's called once the computation is completed, it won't sleep anymore. This is a nice way to probably compute values that are expensive, but you need those values multiple times. And that's it. Those are the features I think are worth calling out in Go 1.21. Of course, there are more features, and I encourage you to look at the release notes. I'm pretty sure you will find something that matches any of your existing use cases. Thank you for watching. I will talk to you next time. Stay safe, keep it up, and don't give up. See you.